So today we are going to start the lesson for the 2025 batch. So we are starting the revision classes today. So as I already told you in my introduction video that we are going to first of all we are going to do a target paper session for the third term examination for your upcoming January examination. After that we can jump to the main revision classes. So this January, that means the term test target paper is likely free classes. So we already told you that we will keep the free sessions, free seminars for you. After that we can move to the main revision classes, guys, right? So today I send you a paper. The paper is like you can see the paper, see the revision paper. Normally this paper is the super revision one. In that paper I gave you some MCQs. This is the MCQ paper, and for the next session I will send you the essay and structure questions, right? In this paper, guys, look at the questions. The first set of question is from the vectors, and the second set of questions is from the sound intensity and sound intensity level. Okay, right, that is the second set of questions. The third one is like in the lenses, concave and convex lenses, and the fourth one is also like third and fourth is convex and concave, right? So for the another one is, the next one is thermometry. It's from the thermometry, and the next one is like Q is equal to ml, Q is equal to ms theta, based on these equations, right? Okay, so this is how I divided the MCQ questions here. So when you are revising these chapter wise MCQs, you can easily catch the points. What are the questions they can ask from this certain chapter? Okay, right. So this is how it's going to work, and we are going to start the lesson now. While doing the lesson, I'll give you some more tips and tricks, and also some I'll give you some advices as well, right? Okay, so let's start the session today. The first, take out your MCQs. Take out your MCQs. So here, guys, right. So look at the first question. Look at the first question. I'm taking the question number 1. So in this question, they are asking, from the following answers, select the response with 3 vector quantities and 1 scalar quantities. Okay, right. So normally we want to know that which are the vector quantities and which are the scalar quantities. Okay, right. I think the answer is shuffled here, like that is not in the proper manner. That means that they are asking 3 vector and 1 scalar. No, some of the answers, we have 5 answers as well here. So there is a typing mistake here. So what I am going to do here is, I am going to tell you, I am going to divide these answers with vector and the scalar quantities. I will divide them to vector and the scalars, right? So look at the answers, guys. So let's divide these answers, okay, right? Number 1 is the vector quantities. Vector quantities. Second one is the scalar. Scalar quantities, right? Okay, so let's divide the answers. Okay, right, let's divide the given answers into scalar and the vectors, right? Number 1 is force. We know that force is a vector quantity. Force is a vector quantity, right? Number 2, the second one, in the first answer, second one is the pressure. We already know that the pressure is a scalar quantity, right? Pressure it has only the magnitude. It doesn't has the direction. So it doesn't has the direction. So this is a scalar quantity, pressure. Pressure is a scalar quantity. The next one is moment of inertia. So we know that moment of inertia, the equation we already studied in rotational motion. So moment of inertia is equal to I is equal to mr square, right? Mr square. So this is the equation. Sometimes it can be changed, right? For the, it's depend on the objects, right? If it is a sphere, that will be changed. If it is a rod, or if it is a hollow sphere or a cylinder, so that can be changed, right? So the basic equation here is for the particle m, if a mass m is rotating by this axis, we can say that the inertia, the moment of inertia of this object is mr square, right? Okay, this is the axis and this is the distance from the axis and the mass. Okay, right, this should be the perpendicular, right? So I is equal to mr square. So moment of inertia is a student's scalar quantity. Moment of inertia, moment of inertia, okay, is a scalar quantity. Another one is angular velocity. We already know that, guys. Velocity is a vector quantity. Angular velocity also a vector quantity. Both has the direction as well, right? Okay. So angular velocity is a vector quantity. Angular velocity. Okay. Angular velocity. Kinetic energy. Work energy. Both are scalar quantities. It doesn't has what? The directions. So work energy, both are scalar quantities, right? The next one is potential energy. We already know that all kind of energy, kinetic energy, potential energy, all kind of energies are scalar quantities, guys. Scalar quantity. So here the potential energy also a scalar quantity. Potential energy, right? Potential energy. Impulse. What is impulse? You know that impulse we already studied in the mechanics. Impulse. So impulse is equal to force into time. Impulse is equal to force into time, guys. Okay, right, force into time. We already studied this equation in mechanics, right? We already know that the force is equal to, F is equal to m into a. A means the acceleration. What is acceleration? Rate of change in velocity is acceleration. So we can substitute here rate of change of velocity. So I can put like this, m into rate of change, that means v minus u, the velocity change. This is the final velocity minus initial velocity divided by time. So this is rate of change of velocity. So we can put this like this. So F is equal to m into, we can put here delta v. Delta means what? Each and every places, the delta means the change. Delta P mean pressure change, delta V mean velocity changes. So delta P means moment changes, right? So it can be changed, right? So delta V divided by T. So I can put here F into T is equal to m into delta V. So what is F into T? This is impulse. So impulse is equal to, students, impulse is equal to m into delta V. Okay, m into delta V. So here we know that what is m? Mass into velocity, right? Mass into velocity changes. So we know that mass into velocity is equal to momentum. So there is a change in momentum. So the change in momentum is equal to impulse. So we already know that momentum is a vector quantity. So change in momentum is also a vector quantity. So the impulse is vector quantity. Okay, right. So the impulse here is vector quantity. Impulse is vector quantity, guys. Okay, right. Impulse is a vector quantity, and Angular momentum, so I already told you momentum is a vector quantity. Angular momentum is also a vector quantity. Angular velocity, angular momentum, everything is a vector quantity. Angular momentum is a vector quantity. Angular momentum. Work is a scalar. Speed is also a scalar because the velocity is vector, speed is scalar. Speed is scalar. Moment of inertia already right here. Angular acceleration is also, guys, vector quantity. Angular acceleration. Angular acceleration is also a vector quantity. Current electricity, we know that electricity is a scalar quantity, right? Current electricity. But in electricity, sometimes revision students know this one, like most of the 25 students, I think they don't know about this electricity part because they didn't study. But normally in circuits, guys, when you are solving a circuit, in Kirchhoff's law, we will study one concept that the name is Kirchhoff law. Something like this. This is R1 resistor and R2, let's say like this. So here, right. So in Kirchhoff's law, when you are applying the Kirchhoff law, so that is we want to take one direction, that is sometimes dependent on the circuits. That means we can take clockwise or anti-clockwise or for a single circuit or a closed circuit here. So at that time only we can we can put the minus values. That means for the direction we can use the minus here, so that we can't just current electricity is a vector quantity. That is a different concept. So this is here basically the current electricity is a scalar quantity. Okay, is a scalar quantity, guys. Okay, right. So the pressure, velocity we already studied. Pressure is a scalar, velocity is a vector, displacement is a vector, displacement is a vector, pressure is a scalar, density is also is a scalar, density is a scalar. Okay, right, density is a scalar, angular momentum, vector, electrical potential, guys, electrical potential is a scalar quantity. We will study this in electric field. Okay, electric potential is a scalar quantity. And electric field intensity, guys, electric field intensity is a vector quantity. Okay, electric field intensity, that means the magnetic field, electric field intensity, gravitational field intensity, those are vector quantities. But the potential here is, electric potential is scalar quantity, right? So here I can write electric field intensity is a vector quantity. Electric field intensity. Electric field intensity. Moment of inertia, there is we already studied. Moment of inertia is a scalar quantity. Weight is a vector quantity. Weight is a vector quantity because weight is a vector quantity, guys, but mass is a scalar quantity. Mass, we already know that. Here when I am drawing a particle here, the mass is m, so the weight here that will act downwards, we know that is mg. So weight is a force, right? So this is a what? It's a force, no? So it's a vector quantity. So weight is a vector quantity here. And then the pressure, we know that scalar, and the velocity is the vector. So everything we know in this question here, guys, right? Okay, so we can choose the answers here. I already told you the answers are shuffled here. So that's why I separate all the vectors and scalars. If you guys show questions, similar questions, something like this, or if you guys doing similar questions like this, so you can approach, you can get the ideas from this MCQs for the scalar and the vector. Okay, right, for the basic quantities. So we know that there are lots of derived quantities are there. So we should know that which are the vector and which are the scalars here. Right, okay. So let's move to the next question. Okay, question number 2. Let's move to the question number 2. So look at the question number 2, guys. The magnitude and the direction of the sum of the 5 vector given in the grid is 1 square represent the magnitude of 1. Okay, right. So here, guys, look at the question here. Look at the question here. So in this question there is a small error. Please change that. So you can see there are several. There are 5 vectors. No, one vector is here. One is here and the other one is here. The next one is here, one is here, and the other one is somewhere here, and the next one is here. So these are the 5 vectors. Please cut down or remove this vector. So in the question, so please remove this vector. Okay, please remove this vector, guys. Please remove this vector. Okay, right. So I'm going to erase this one. So these are the given vectors. What they are telling here is, guys, 1 square represent the magnitude of 1. So here, so the first one, so we can see this one. So the one small square that represent 1. Okay, right. So look at this vector. How many squares are there in that vector? So there are 5 and 1, 6 squares are there. So the magnitude of the vector here is 6. The magnitude of the vector here is 6. So the magnitude of the vector here is 6, guys. For this one, it's 5. It's 5. And for this one, we can say like, for this one, we can't measure the square. It's easy, but we can't. It's hard to measure the square that is inclined, right? By the way, what you can do here is you can use the Pythagoras theorem. So we know that if we divide these vector by horizontal and the vertical, that means if you resolve this vector, guys, you can get this is like 5 and this is like 5. So if you resolve this vector into two direction, one is like here, vertical and the horizontal. So when you resolve this vector into vertical, you can get 5 boxes. When you divide this vector into horizontal, you can get 5 vectors. That means this is the resultant vector here, guys. So the resolved vector is something like this. So this is 5 and this is 5. For these two vectors resultant, and sum is like from head to tail, right? So we can draw the tail to head. Okay, right. So here we can draw the resultant here. So this resultant is equal to this resultant. Due to Pythagoras theorem, we know that this is 5 and this is 5. We can write here 5 root 2. 5 root 2. Okay, right. Also we already know that 5 square plus 5 square, that is 2 into 5 square. So 5 square, when the 5 is coming when you take the root for the 5 square, that is 5, so 5 root 2. Okay, so this is 5 root 2 here. This is 5 root 2 here. For this one, how many boxes it's covering? So it's like 1, 2, 3, 4, 5, 6, 7 boxes. So the value is here 7. For this one, like 5 plus, it's like 4 plus 1, 5, 10. So it's 5. So these are the vectors they given. Right. So what we want to do here is we want to get the resultant of these 5 vectors, guys. So for this question, we can use the vector addition. So how to do the vector addition? We want to draw, or we want to complete we want to put all the vectors, right, we want to add all the vectors, and from the starting point to the ending point we can get the resultant. Okay, right. So I'm going to add these all vectors. So look at this one. So we can add like this. So I'm going to write down here. So this is 6 and this is 5. Here I'm writing the 5, and then this is like something like this. So I'm going to draw these boxes as well, values as well, 5, 5. So this is 5, right? Okay, so this is 5 root 2, and it's like 7. So 7 means this is 6. So 7 means this is already 5, so there will be 2, right? So it's like 7, right? From this point it's 7, and this is 10. Okay, and this is 10 here, and this is 10 here, guys. Okay, you can see like this. So in this case 5 plus 5 10, this is also 10, and this is 7 5. So total length here is 12, and here 6 is only, this is 6. So if this is 12, if this is 6, we know that guys, we know that from starting point to the ending point we can get the resultant. Starting point to the ending point, we want to connect them. So this is the starting point and this is the ending point. So starting, we add all the vectors here. This is the starting and the ending. So when you connect the vector from the starting point to ending point, so this is the resultant here. So this is like 6. This is like 6. So for this question, the resultant here is, guys, is 6. Okay, right. So horizontally towards the right or towards the east is 6. So the resultant here is 6. So which is the correct answer? The fifth one is the correct answer for this question. So we can get the answer. Answer is fifth answer. Answer is the fifth answer. Okay, right. So let's move to the next question. Okay, please write these down. Please write these down. Let's move to the next question. Okay, right. So when the live is going on, guys, you can pause the live and you can draw this. Yeah, we can. You can write these down. Okay, right. So before going to the third question, I am going to give you a similar questions here. Similar question here. I'm going to give you a similar question here. Guys, please okay, right. Write down this question and try to get the answer for this one. Maybe you already do this question, similar question in your theory classes as well, but I'm just remembering this one. Okay, I'm just remembering this question. Right. So here this is like this. Okay, so for this question, what is the answer? For this question, what is the answer? You want to get the resultant of these set of vectors. So what is the resultant here, guys? It's very easy. So we already know that this is A, B and B, C. So resultant of the A, B and B, C, we want to connect the starting and the ending point. So here AC, already there is a AC. From this A, B and B, C, we get the second AC here. So there are two AC here. Here also the same CD, DE, the resultant is CE. So there is a second CE here. C, E, F and FG, the resultant is EG. The resultant is EG. The second EG also here. So there are 2 AC plus 2 CE plus 2 EG. So we already know that, let's say, if it is like this, let's say if it is like this, so A, C, E, G, if you want to get the resultant for these vectors, it's very easy. from the starting to the ending point, we want to connect these. So the resultant here is for this AC, CE, EG. The resultant is AG here. So there are 2 AC, 2 CE, 2 EG. The resultant is 2. The resultant is 2AG. Okay, the resultant is 2AG. So for this question, these kind of questions sometimes they can ask you, right? Okay, so let's move to the third question. Let's move to the third question. Right. Look at the third question. So third question here is, it's all about the change in momentum. Change in momentum. So let's read the question. A ball coming towards a bat along the ground is turned by an angle 120 degree, only changing its direction. The change in its linear momentum due to this with its magnitude and the direction is. So they are asking for the change in momentum, right? They are asking a question based on the changing momentum. So it's very easy. The changing momentum, that means final momentum minus initial momentum. Okay, right. So let's do the question here. So the bat is here. So this is the, let's take this is the bat. So the ball is coming like this. The ball is coming like this, and he's changing the direction by putting the bat something like this. So you already know that in cricket, you already know when the ball is coming. So you know the famous shot, Dill scoop, like when he is standing. Who is that? The Dilshan, you already know that. So when he is standing, when the ball is coming, he will do something like this. Okay. So when the ball is hitting, the ball is hitting this surface and ball is going up, right? He's just changing the direction. So in batting, in cricket, we always changing the directions. Okay, we always changing the direction using the bat, using the surface. So when you, that is it's a science, guys. The sports, the cricket is a science, right? So it's a physics. So there are lots of physics concepts using in the cricket as well, in football also, in every games there is physics. Okay, we can't avoid the physics, right? So normally in swing, out swing, so everywhere, so the Bernie is also there. So it's a very interesting subject. You should connect, when you are studying physics, you should connect the reality with the theories, with the concept. So when you are connecting like this, you can easily understand the concept. And so normally most of the students, the problem when you are studying the physics, students facing the problem is like, so students are trying to memorize the theories. So that is not a good behavior. That is not going to work for you guys. Don't memorize the theories. Try to understand it. When you understand the concept, you can easily eliminate the MCQs. You can easily understand the question and you can write the answers. When you memorize it, so let's say like when there is a question is coming like this, you should do like this. So some kind of teachers, they will tell you like, if you saw a question like this, do like this. If you saw a question like this, do like that. Don't do like that, right? If you understand the concepts, if you know how to add the vectors, you can do this. So you should be clear, you should be focused on how to add vectors. You should know that one. So please clear the concept and you can easily get the answers, right? If you are doing questions, while you are doing questions, if it is hard to understand the question, that means you are memorizing the theories, you are not understanding the theories. So the problem is with you guys. So please try to understand the concept, right? Okay. So the similar concept like this. So let's go to the question. So the ball is like this. So the ball is coming like this, and okay, right. So the ball is coming like this, the mass here, m, and the velocity is v. The velocity is v, the velocity vector is v. And we know that this is like 120 degree, okay? Right, so this is the horizontal line here, horizontal line. So this is also the velocity is also v. The ball's velocity is not changing, only the direction is changing, only he is changing the direction here, okay? Right, so here what you want to do here is you want to get the change in momentum. We already know that change in momentum is impulse, okay? Right, right, change in momentum is equal to impulse, right? Okay, so the change in momentum, let's write the equation for the changing momentum. So the change in momentum is equal to final momentum minus initial momentum, okay? Right, final momentum minus initial momentum. So this is a vector quantity, so we are going to add the vectors as well here. That means we want to show the vectors also here. So what I'm going to do here is I'm going to put the vector and mass m into v. The final momentum is m into v. So the value is m into v, the magnitude is m into v, the direction is like this. Minus, so this is the initial one. So initial is like this. So we want to put the directions, we want to put the angles as well. So here, look at this, guys. So we know that, so these two vectors are equal. So I can draw a perpendicular line like this. This is perpendicular line. If it is perpendicular, we know that this is 60 degree and this is 60 degree. If this is 60, this is perpendicular, so this is 30 degree. This is also 30 degree. Okay, right. So we can draw this one as also. We can draw this also. So we can draw this like this. Okay, right. I can draw like this as well. So I'm going to draw like this. So here, so if this is 30, this is also 30. If this is 30, this is also 30. So from this horizontal line, so this MV is making 60 degree here. So likewise, I'm going to draw here. Likewise, I'm going to draw something like this. Okay, 60 degree. So this is MV. Okay, so look at this one. So I am subtracting the vectors here. So we can change this subtraction to addition by changing this direction. So minus into direction, that means that will change the direction. So here I can write like this, MV plus, so opposite direction, 60 degree. So for these two vectors, I am going to add. Okay, right. So I can add the vectors here. This is MV, and from the horizontal line, it's making the 60. It's making the 60. This is also MV, right, 60. So for these two vectors, I can get the resultant like this, starting to ending. So this is the resultant here. So look at this one, guys. This triangle is this is also 60, and this is also 60. You can say this is MV, this is MV, this one also MV. This is also MV, right? Okay, so it's very easy to find the resultant here. So this is the resultant. Sometimes students won't know this method. So how you got this answer, sir? Right, I will tell you how to get the answer for this one using the method 2 also. Okay, method 2. So I'm going to write the method 2 here. I'm going to write down the method 2 here. Okay, right. So this is the method 2. So in this method 2, guys, in this method 2, what I'm going to do here is I'm going to take the change in momentum into two directions. So here we took the directions now here. Directly we took the directions here and we got the answer here, right? For this one, for the second method, I'm going to take two perpendicular direction, and I'm going to calculate the change in momentum. Okay, right. So here, let's start the change in momentum. So first of all, we know I'm taking this direction. That means this surface, like the bed, right? Okay, in this direction. So in this direction, I'm going to find the change in momentum. Okay, right. Look at this one. Initially, the momentum is like mv cos 30, that is in this plane. Okay, right. Look at this one. mv cos 30, that is also in this plane. So the final momentum is mv cos 30 here in this plane. So I can write like this: mv cos 30 minus change in momentum, no? So the final momentum minus initial momentum. So the final is mv cos 30 minus mv cos 30. Initial one is also mv cos 30. mv cos 30. So in this direction, the change in momentum here is, guys, 0. Okay, right. So now what I'm going to do here is I'm going to take the direction perpendicular to the surface, to the bed. Okay, right. So now I'm going to take the perpendicular direction. I'm going to take the perpendicular direction to the surface of the bed. Okay, like this. So right, for this one I'm going to take. So if I take this direction, in this direction I'm going to find the change in momentum. So look at this one, final momentum, mv cos 30, mv cos 30, mv sin 30 in this direction. mv cos 30, mv sin 30, mv sin 30, that is in this direction. And the initial one is mv cos 30, mv cos 30, mv sin 30. So mv sin 30 is opposite to this direction. So I'm going to put minus mv sin 30, because we took the direction in this one, but the initial is mv cos 30, mv sin 30 is toward this direction, so opposite to this direction. So that's why I put this minus here. Okay, right. So now what we can do here is we can add these two vectors. So we can get 2mv sin 30. 2mv sin 30. Sin 30, we know that it's half. So half and 2 both can cancel. So the value is mv. Okay, right, mv. The direction is in this direction. We took in this direction, no? So in this direction, the change in momentum here is, guys, mv. Okay, change in momentum here is mv here. So for this one also, so we know that we can get the angle here. We can put the angle here. Look at this one. So this surface is like from the we can say that this is like, we can take the, yeah, this is 60 plus 30 90, 60 plus 30 90, so it's all it's 180 degree. So this is like from this horizontal line, it's 30. Okay, right. So you can say like this, and also you can put the angle like this one also. So from this one also you can, from like this also you can put the angle, and also you can put this angle as well. Let's put this one. It's easy. So this angle as well, we can put this direction. Now we took this direction. So that is from the horizontal line 60 degree. Horizontal line 60 degree. Okay, right. Horizontal line 60 degree. M into V. This is the resultant. Okay, right. So these are the two methods. You can follow both methods here. So we can get the answers. So the third one, we can go for the answer which is correct. Yeah, the fourth one is the correct answer. For third one, fourth one is the correct answer. So the answer is fourth one. So the answer is fourth one here. Okay, right. So let's move to the fourth question. Let's move to the fourth question. So look at the fourth question, students. When two forces of equal magnitudes are added as shown in the figure, the magnitudes of their sums were Fa, Fb and Fc respectively. The answer showing the correct order of these forces Fa, Fb and Fc is, right? Okay, so here this is also based on the vector addition. Right, let's discuss some basic things in this vector addition, guys. Okay, right, okay. So what I'm going to do here is in the fourth question. Okay, right. So in this question, the first one is something looks like this. Okay, right. So this is F and this is F. So these two forces are perpendicular and equal. I'm going to give you one exam point here. Okay, right. I'm going to give you one exam point. Okay, right. If there are two forces, if the given two forces are equal, the given two forces are equal, guys, the resultant, I'm going to draw like this. If the given two forces are equal, the resultant, that will be divide this angle into two parts. Those angles are equal. If these angle making theta, the resultant will be like this. If this is theta by 2 and this is theta by 2. Okay, right. If the forces are equal, when we are taking the resultant here, from the resultant, both forces will make the same angle here. So this is theta by 2 and this is theta by 2. If the angle are making like this, so you can write down this keynotes here. If this is theta, let's take these two are F. So here the resultant will be like this. The resultant will be like this. Okay. So this is the resultant and this will be theta by 2 and theta by 2. Okay, right. For these forces, if you want to get the resultant, we can resolve the forces here. Look at this one. F cos theta by 2, F sin theta by 2. I'm going to resolve the forces for this one. Okay, I'm going to resolve the forces for this one. So I'm going to get the resultant here. Right, these are the forces, no? These are the forces. Right, so these are the forces. So I'm going to resolve these forces. So this is like F cos theta by 2, F cos theta by 2, F cos theta by 2. So 2F cos theta by 2 in this direction. And F cos theta by 2, perpendicular one is F sin theta by 2. F sin theta by 2. So this is also F cos theta by 2, F sin theta by 2. F sin theta by 2. So these two forces can be cancelled. So the resultant is equal to 2F cos theta by 2. Okay. So the resultant here is, guys, the resultant here is 2F cos theta by 2. 2F cos theta by 2. If you remember this one, you can easily get the answers like this. Okay. Right. Okay, guys. So this is the exam point you should remember. Let's move to the A, B and C vectors. Okay, right. So the first one is something like this. F and F. For this one, we already know that the resultant is like this. We know that if this is 90 degree, that will be divided into two part 45, 45. 45 and 45. So if this is 45, we know that the resultant is 2f cos theta by 2. 2f cos 45 degree, cos 45 is equal to 1 over root 2. So 2f cos theta by 2, 1 over root 2. So the answer is root 2f. Okay, right. Normally, we should know that two same forces acting like this, if two forces acting like this, the resultant will be root 2f. You already know these things, right? Okay, so the resultant is root 2f for the A. For the FA, the resultant is root 2f. Let's move to the B. So B part also same thing. B part also same thing. This is F and this is F, and the resultant will be like this. So this is totally 60 degree, guys. So this is 30 and this is 30, right? So 2f cos theta by 2, the theta by 2 value is 30 here. So the resultant here is, the resultant is FB, no? FB here is 2f cos 30. Theta by 2 here is 30, no? Right, cos 30. So cos 30 value is equal to root 3 by 2. So when these two cancel, so the resultant is root 3f. Okay, right. Let's move to the C part. The C part, look at this one. This one also same. This one also same concept. We can use the same concept here as well. So these two are equal forces. So the resultant will divide the angle into same two, right? Two parts, same two, equal and equal, same two parts. So this is like 60. The resultant divide the angle like 60, 60. So the resultant here is FC. For the C part question, the resultant they said FC is equal to 2f cos theta by 2 value is 60 degree. So cos 60 is equal to half. So the resultant here is for the FC is f, right? So this is FA. FA is equal to root 2f. FB is equal to root 3f. FC is equal to f. So this is the answers for the fourth question. So for the fourth question, root 2f, root 3f, f. Root 2f, root 3f, f. So the answer is the second one. In this answer is the second one. In this answer, students, the second answer is equal to root. There's a typing mistake. They didn't mention the f there. So please put the f next to the root 2 in the second answer. Okay, right. For the A part, for this one, FA, it's root 2f, not root 2. Okay, so there's a small change in that question. Right, that's all. We can move to the next question. Question number 5. Question number 5. Right, okay. So before going to the question number 5, students, I'm going to give you a small question. Okay. Yeah, I'm going to give you a small question here because you should know this one. That's why. Okay, right. So let's say like this. This is an exam point. I'm going to give you an exam point. So this is an exam point. Right. So in this exam point, yeah, like let's take, there are two forces. This is, let's say this is F1 is equal to F. This force is F1, that is equal to F. Okay, right. This is F2 is equal to F. So if they ask F1 plus F2, that is very easy. We can get the answer F1 plus F2, no? Right. When you add these two vectors, if this angle is equal to, let's say, theta, the resultant is something like this. We already studied, no? The resultant is like this. So I can draw the rectangle here. So right, I can draw like this. Right. I can complete a rectangle here. Right. So right. So if this is F1, this is F2, we know that the resultant here is F1 plus F2. Resultant here is, students, F1 plus F2. So if this is F1, equal and opposite, so this is also F1. If this is F2, this is F2. So F1 plus F2, the resultant is F1, F2. We already know this one. For this one, F both are equal, right? So if this is both are equal, this is theta, no? The total angle is theta, no? If this is both are same, both forces are same, we know the resultant here. Resultant is equal to F1 plus F2, right? The resultant is equal to, students, F2F cos theta by 2. 2F cos theta by 2. We already discussed now here, right? Same thing, same thing. So this is exam point. So this is number 1. Let's say if they are asking F1 minus F2, this is very important. If they are asking F1 minus F2, so look at this one. F1 is equal to F, F2 is equal to F. F1 minus F2 means F minus F is 0, no? You can't say like this because this is not a scalar, this is a vector quantity, right? Okay, right. For these kind of questions, we can easily do this one also, right? Look at this one. So what I can do here is, so F1 minus F2, so we already studied about the parallelogram law. So here for the F1 minus F2, we can draw like this. We can draw the parallelogram like this. So F1, so let's take, so if we already know that, no, so this is F2, no, so we are going to draw the minus F2. So how to draw the minus F2? That's very easy. Minus F2 means opposite to this direction and same magnitude. So opposite to this direction is minus F2, right? Minus F2. This is minus F2, that is equal to minus F. We already know that one. That is equal to minus F. So this is F1 and this is minus F2. So let's complete this parallelogram. Okay, right. So if we complete this one, this is minus F2 and this is minus F2. This is F1 and also this is F1. This is F1. So what we can do here is we can add both of these vectors. So if we add these both vectors, so how to add the vectors? Look at this one. So this is minus F2 plus F1. So look at this one. Minus F2 plus F1. That is equal to what? F1 minus F2, no? Right. So that is the resultant. So the F1 minus F2. So this is the F1 minus F2 here. F1 minus F2. So from this trick, we can get the F1 minus F2 value here. Right. So we know that if both forces are same, the resultant something like this. That means F1 plus F2. So this is F1 plus F2. Don't so I say don't complex this one. So this is F1 minus F2. This is F1 plus F2. Okay, right. So if the angle between these two forces are theta, so this is theta by 2. This is theta by 2. This is theta by 2 and this is theta by 2. So if you are going to find this F1 minus F2, students, so it's very easy. This is perpendicular, no? So this is perpendicular. This F2 is equal to F, no? This F1 is also equal to F. F1 is also equal to F. So F cos theta by 2 or F sin theta by 2. So the value here is this one. For the value of this one is F sine theta by 2. So this is f cos theta by 2, this is f sine theta by 2. So this is f sine theta by 2. So this is f sine theta by 2. So the resultant here is, for the f1 minus f2 here is, this is f sine theta by 2, f sine theta by 2. This is the resultant for the f1 minus f2, no? Right. So the value is 2f sine theta by 2. Adding f sine theta by 2 plus f sine theta by 2 is equal to f1 minus f2. So f sine theta by 2 plus f sine theta by 2 is equal to 2f sine theta by 2. So you should remember this one also in examination. So any other, when you are facing the question, do you know this f1 plus f2 and f1 minus f2, you can easily eliminate the question. That's very easy, right? So please write down these exam points here. Okay, now we can move to the next one, I think. Yeah, everything is finished. Yeah. Okay, so we can move to the next question now, students. Question number 5. Let's move to the question number 5. Okay, right. So I'm going to erase this one. So you already know that to get the resultant or sum of vectors and the resultant vector both are same, right? Sum of vector and the resultant vectors both are same. If you want to get the sum of vectors or to get the resultant of the vectors, what you want to do, guys, here is there are three methods. Number one is parallelogram. That is what I told you there. Okay, right. So there is an equation also there for the parallelogram theory. Tell me the equation. R is equal to p square plus q square plus 2pq cos theta, right? Okay, so the parallelogram theory, so we already know that R is equal to, you want to complete a parallelogram there, so R is equal to root of p square plus q square plus 2pq cos theta. Okay, right. So this is the theorem. So if P and Q, if PQ, two forces acting like these, the resultant R will be equal to this. So here what you want to do here is we want to complete a parallelogram here, right, like this, and you can get the answer. Okay, so directly you can use this equation also, but so normally if you resolve the vectors, that's very easy. Okay, right. So the resolving of vector, each and everywhere we can use that one, and also this one also. The second one is triangle, right? Second one is the triangular law of forces. For the triangular law of forces, like I can say like this: if this is P and if this is Q, from the starting to ending point you should draw the, so if this is starting, this is starting, and if this is ending, so we can connect both. By like this. So this is the resultant here, R is equal to P plus Q. So this is the triangular law, and the other law is polygon law, right? Polygon law of forces. So we know that if polygon law is also same like the triangular one, so here if we took two forces, that can be a triangle, and if you took many forces, that can be a polygon, right? That's all. So in polygon law, we already know, we already did a question somewhere there, something like this. So we already did a question, no? Right? Let's say this is F1 and F2, F3, F4 and F5. If you want to get the resultant of all these forces, the resultant will be like this. This is the starting, this is the ending, so the resultant is here. So this is the resultant, that's all. Very simple. Okay, right. So you should remember this one, guys. So that's why write down here. Okay, right. So let's move to the question number 5. right? Okay, so the question number 5, the magnitude and the direction of the resultant force of the force system shown on the right is one large square represent force F. Okay, right. So they gave us a force set of number of force like this. So there is an error in this question. What you want to do here is, this is the point O, no? So here there is a force here, and here there is a force, and here this is the next vector or the force, because the force is a vector, right? The next one is here. Okay, right. So here one force is missing. So what you want to do here is, you want to draw the next one like this. Okay, so if we take this is a box like, so you want to draw another force in this box. We already have one force here now, one is here now, there is a box now. You want to draw a force diagonally. Okay, you want to draw a force diagonally, that's all. That's all. Right. So what we are going to do here is, we are going to get the resultant of these forces. We are going to get the resultant of these forces. Right. In this set of forces, if we are going to get the resultant of this system, it's very easy. We can easily resolve the forces. Okay, we can easily resolve the forces. For this one, look at this one. For this one. All right. Before that one, let's start from here, because in this side this is 2f. No, this is 2f. This is also 2f. So both can be cancelled. Each and equal and opposite forces. No, both can be cancelled. So these two can be cancelled. We don't want to worry about that one, right? Okay. So another thing here is, I'm going to resolve this one and this one. Okay, this one and this one. So if I resolve those forces, look at this one. So if I resolve this force, so this is like cos and sine values, no? So this force is created by this force and this force. Like this is 2f and this is 2f. Yeah, this is 2f. So the resultant here, this is the resultant. The resultant is here. The resultant is created by these two forces. If we resolve this resultant force into two, what are the forces? Horizontally 2f and the vertically 2f. So we can represent this resultant force by two forces. That's all. That is for resolving, right? Okay. So what we can do here is, these forces are cancelled, no? Right. Okay. If I resolve this force into horizontal, the horizontal force here is 2f. If I resolve into vertical, so the vertical is 2f. Vertical is 2f here. And here, if I resolve this one, so this one, I'm resolving this one. This is f and this is f. So we can write like this. So this is like downwards f and this side f. Okay, this side f. So look at this system now. We have only horizontal forces and vertical forces. Look at this one. We have 2f upwards. We have 2f force upwards, and there is already a force f here. We resolve this one. So there is another force coming downwards here. So there are 2f. Okay, there is a force now here f. So we resolve this force now into two pieces, f and f. F and f, we resolve these into two, no? Right. So f plus old f, so that is 2f. So there is already 2f here, That means the earlier one is cancelled, but the resolved one of this resultant is 2f. So 2f plus f, 3f. So this is 3f. So these two can cancel. So the resultant here is 3f. So for this question, the answer is, students, 3f. So, okay, right. So the 3f is the answer. So the fifth question, the answer is the second answer. Okay, right. So the answer is the second answer. Answer is the second answer. Right, let's go to the sixth one. I think sixth, seventh and eighth question, 8, 9, 10, all questions are similar questions like this. Okay, so you can practice on this question, so I can give you the answers, guys. For the right, yeah, we can simply do those questions, similar questions, so we can't waste the time here. So you can yourself, you can do the questions. And the sixth one, look at the sixth one. Right, so okay, right, so look at the sixth one. From the responses given below, select the response with two vectors and one scalar. Okay, so two vectors and one scalar, we want to select them from this set of answers. For the sixth one, students, the answer is the first answer. Please try this question yourself. The seventh question, the answer is the third one. And the eighth question, there is a small error in this question. The eighth question, look at the right. Look at the eighth question. Select the correct response of this magnitude and the direction of the change of velocity of the pendulum bob during its motion from A to B. Right? Okay. So during its motion from A to B, that is, we already know that. What we want to do here is we want to get the change in velocity. That means final velocity minus initial velocity. So that will be the resultant of these two vectors, right? That will be the resultant of these two vectors. Okay, right. So we can get the answers easily for this one also. But the answer here is there is a change in the answer. But by the way, I am going to explain this one. Okay. By the way, I am going to explain the eighth question here. Okay, right. Before going to the eighth question, I am going to give you an example. Okay, you should know this one, guys. So that's why. Let's see. Let's do a question here. Example question here. Okay, right. Let's take. There is a circular motion is happening. A circular motion is happening here. Okay, there is a circular motion is happening here. Okay, so let's take, this is like Vp, the velocity is Vp, that is equal to V, and let's take this is like Vq, that is also equal to V. Okay, this velocity is Vp and this is Vq, same. These two velocities are same. That means a particle, a mass, a small particle is moving in a circular path. So here, what you want to do here is you should find the change of velocity of in these two positions. Okay, in these two positions, you should find the change of velocities here. Right. If we take the angle between these two positions are theta, they are asking the delta V. That means the change of velocity between this time period, delta V. That means Vq minus Vp. Final velocity minus initial velocity. Right. For these kind of question, what can we do? There is a small trick is there to do this question, right? I'm going to draw some lines here. Look at the question. Right. What I'm going to do here is I'm going to extend this line. And also I'm extending this line. Okay. I extended these two lines. I extended these two lines here, guys. Okay. Right. Look at this. Look at this question. Very careful. Right. So this is VQ. So we know that this is 90 degree and this is 90 degree because tangent, we already know this is tangent. So this is also tangent. So this is 90 degree from the radius. So this is radius now. This is RR. So right. So what I'm going to do here is I'm going to represent these forces here. So the direction is here, no, the VP direction is here, no, just I'm going to put the VP like this. This is VP. Okay, right. the VQ is something like this. So this is VQ, no? So this is VQ. So here, this is 90, this is 90, so this is theta, so totally 180. If this is theta, we know that this is 180 minus theta. 180 minus theta. So 180 minus theta plus theta is equal to 180, 90 plus 90, 180. So totally, in this shape we can get 360 degree, that's okay, right? If it is 180 minus theta, this is theta, this is theta, okay? And also, we know that this Vp is equal to V and this Vq is equal to V. This is also V and this is also V. So, look at this one. There are two forces. There are two forces acting, equal forces acting between an angle of theta. Okay, right. So, we know that this is Vp and this is Vq. What they are asking here is, we should find the VQ minus VP. So, if this is 2, we already know that the vector means all the physical quantities with directions. So, we can use the vector rules for all the physical quantities, which is the vector quantity. That means which physical quantity has magnitude and directions. Velocity, we can use the vector rules, okay? And also for the acceleration we can use, momentum we can use, right? Electric field intensity we can use, right? Likewise for the all the vector quantities we can use these rules, okay, right? So here we want to find the VQ minus VP. We want to find the VQ minus VP. That means what? That is a vector subtraction. That means we already find the answer. I thought here I already erased that one. I gave you what is the value? 2f sine theta by 2. Yeah, so 2f sine theta by 2. So VQ minus VP is equal to 2f sine theta by 2, right? VQ plus VP, that means the addition. If it is the vector addition, we know 2f cos theta by 2. 2f cos theta by 2. Okay, right. So VQ minus VP is equal to 2f sine theta by 2. So here we can easily get the answer. So for the f, we can use the velocities here. Both velocities are same. So v, 2v sine theta by 2. 2v sine theta by 2. Okay, right. So here we can easily get the answer. We can easily get the answer, students, right? So this is also an interesting part. So likewise, you want to use some tricks, okay? So to solve these kind of questions. So there we studied for the force. Here we are doing for the velocities. Both are vector quantities, so both rules we can use, right? For that rule, we can use both quantities, right? That's all. Only the quantity is changing here. That's all. So for these two forces, for these two velocities, if you want to find the subtraction, that means the change, that's very easy. That is 2f sine theta by 2. Okay, right. So you can easily use this one as well. Okay, right. And also, look at this one, guys. Right. Like, if you want to find the VQ minus VP, right? If you want to find the VQ minus VP, this is VP, no? So this is minus VP. Look at this one. This is VP, this is VQ. So VP plus, look at this one, right? So this is VP and this is VQ, no? If it is VP and VQ, the resultant will be like this, VP plus VQ. For the vector addition, VP plus VQ, something like this. If I want to take the VQ minus VP, we know that this is VP, no? This is VP. Opposite direction, this is minus VP, this is VQ. Okay, right. For these two addition, what is the addition here? For these two forces, I am going to get the addition. So addition is VQ plus minus VP. That is what? VQ minus VP. So here, if this is minus Vp, the resultant will be towards the center. The resultant will be towards the center. The resultant will be towards the center. That is what? The resultant here is VQ minus Vp. VQ minus Vp. That is what? VQ minus Vp is what? Change in velocity. So look at this one. Let's say this point is A. Let's say this point is B. If the particles start the journey from A and coming back to B, the time taken, let's take the time taken here is T. Let's say the time taken here is T. So delta V divided by T, that means between these 2 points, the change in velocity divided by time. Okay, change in velocity, rate of change in velocity between these two A and B is equal to what? What is rate of change of velocity? Is acceleration. So this is acceleration. So the acceleration of the particle is moving in a, so when a particle is moving in a circular path, the acceleration of the particle, that must be towards the center. So that is true here. Okay, right. So likewise, there are many interesting things are there, students. So here I explain you the vector part, but here, and also I explain you how the centrifugal force or centrifugal acceleration is working as well, right? Okay. So here I give you an idea. Using this idea, you can get the answer for the 8th question as well. Okay, 8th question as well. So look at the 8th question. So 8th question, there is a bob is moving like this in a circular motion. In a circular motion, the bob is moving like this in a circular motion, circular path. So here the velocity is 10 ms minus 1. 10 ms minus 1. So this is in a circular path because the length here is L. This is also L. Right here, the velocity is 10 ms minus 1. If you take the change in velocities, right? If you take the change in velocities, that 100% that will be 100% sure that should be towards the center. That should be towards the center. Delta V, that should be towards the center, and that is also equal to, that delta V is equal to, students, 2V sin theta by 2. 2V sin theta by 2. So here look at this one, delta V is equal to 2 into the velocity here is 10 sin theta by 2. So we know that this is theta, entire angle between these two lines are theta. This is the theta, no? Right, because the forces, the velocities are acting in these 2 points, no? So this is theta. Here the velocity between this velocity and this velocity, the angle here is theta. Okay, right. So this is theta here. So theta by 2 here is 30 degree. So sin theta by 2 is sin 30. So these two can cancel because this is half, this is 2. So the rest is 10 ms minus 1. So that is always towards the center. Yeah, that is always towards the center. So in this 8th question, I already told you there is a small mistake in this question. The mistake is that please change the direction of the answer for the third one. So write down the answer for the third one, change the direction upwards 10 ms minus 1. In the third answer, they given like towards the right, no? Like this, no? This is the answer, no? This is wrong. Please cancel this one and put the answer for the 8th question like this. Okay, right. And also, right, for the 9th question, yeah, we can do the 9th question as well. That is also easy question. Please try yourself. For the 9th question, you can get the answer, second answer. And the 10th question, question number 10, the answer is the second one also. Second one, right? Okay, so these are the answers for the rest of the question. Right. So students, today what we discussed here is, students, the vector part we discussed, and we do some questions here. We did like, we discussed first 10 questions here, 10 MCQ questions. So I gave you the basic idea how to do this vector question, right? Normally in final examination you will get one normally vector question. So using this idea, definitely you can smash them. Okay, right. Okay, that's all. So our revision is going like this. So chapter wise I will do the question. So in the next set of question I will go to the sound intensity part, and I will discuss those questions. After that I will move to the heat, lenses, heat. Likewise we can do all the questions on that paper, right? Okay. Normally when I am conducting the main revision, that means targeting the final examination, so I will start that from like January, the third week, the midweeks I will start the main revision classes. In that main revision classes I will do questions based on the past papers. One is paper class. In the paper class I will do 1979 to 2024 MCQ. I will cover up all the MCQ structure essay that is in the paper class, and chapter wise I will give you the keynote, summary note for the chapter. So in this question, in this vector part, that is very simple. Now there is no summary note, only on the key points I gave you here, right? There are very short of key points are here. Okay, right. So in our final main revision classes I will cover up all the key points, chapter wise things and everything. So that should be a game changing series for you guys, definitely, for the main revision classes students, right? Okay, so please try to join with us so we can get good results. So we have a good plan, and also we have another series, the topper series, that means the 2025 next gen revision topper series papers. So in that paper, students, I will do MCQs like this. That means the mixed question, like that paper is fully chapter wise. No, from the kinetics I will start the paper classes. So after finishing the kinetic MCQs I will move to the forces, and after finishing that one I will move to the moment of forces, right, again to the Newton's laws of motion. After finishing that one, work, energy, power, and hydrostatics, circular motion, rotational motion. So chapter wise I will cover up all the MCQs in that paper classes. After that, in the full paper class, in the revision classes, the full paper class, I will do, first of all I will do a paper that is based on unit 1 to unit 4. Little by little I will increase the limit, like 1 to 4, after finishing 1 to 4, 1 to 5, 1 to 6, 1 to 7, 1 to 8, 1 to 9, near to the examination. If it's like we have examination on October, when I am doing classes like August, September period, I will cover up all the lessons 1 to 11 range. I will do them, because some of the students didn't finish the syllabus, so that's why I'm doing the full papers like 1 to 4, 1 to 5, 1 to 6, 1 to 7, and I will step by step I will increase the range of the syllabus and I will do the full paper. So in our main revision classes we have full papers and past papers, full model papers and past papers, right? So those are the information, students. So today we discussed this one. In the next chapter we will study the sound intensity part in our next class. So let's meet you in the next class, students. Physics is simple.